Hello and welcome to Realize Live Strategic Sustainment Planning and Future-Proofing Engineering for Aerospace, Defense, and Government, supported through system integration of your digital thread. First, I'm going to start with a ProStep overview. Then we're going to go and review some goals and challenges within this environment, talk about integration solutions and strategies, and then finally, the ProStep API for the digital thread. ProStep was founded back in 1993 and came out of a consortium in Europe of automotive tier ones and OEMs. So back in the 1980s, it was expensive to produce cars, and they figured out that data exchange and collaboration between suppliers and OEMs was complicated and costly. And so they came up with ProStep nonprofit group, this ProStep IVIP in the lower left, as well as the ProStep for-profit group in order to solve some of these challenges of interoperability. Our ownership is at the bottom, including many tier ones and OEMs in the automotive sector, and each own about 10% of ProStep. ProStep itself is a neutral player within the engineering community, so we partner really with everyone since our inception. That includes different PLM and CAD vendors like Siemens, and also ALM and SDM, and ERP, and other types of technologies like Adobe for 3D PDF, and other partners in order to bring in technology to our product stack. But this makes us pretty unique within the industry that we have these great partnerships, that we maintain them for a long time. Siemens is obviously one of our partners. We are a PLM Foundation partner. They support our commercial off-the-shelf connectors for Teamcenter, Teamcenter Enterprise, and then different applications within Teamcenter, as well as providing expertise for Teamcenter in the domains of integration, migration, data exchange, and visualization. Next, we'll review some of the goals and challenges within the sector. So there are different challenges within engineering domain and data retention, starting really with the top and the product definition, all the way down to the manufacturing and detailed component level. And the first is cross-domain integration. So this is trying to get the mechanical designs, electrical, and the software all to work together on coordination. The second is the vertical model. So trying to bring the product definition and the requirements and link those to really the component level of what those software artifacts are and hardware artifacts, and link that data together to get a real complete system model. And then third is the validation, and trying to bridge that V model in order to make sure the product is what it's intended to be, that it fulfills the requirements, and that the components of it also fulfill their specific requirements with analysis. So we see that distributed data is really the reality today. Data is mastered in different sources from different domains, like different repositories such as Teamcenter. And we find that one solution might not be desirable for everything. You have legacy solutions that have been used for a long time. Everyone knows how to use them, and they're very valuable, and you've gotten good product out the door with those. And the cost of changing of those solutions is pretty high as well. But we want to find a means of capturing that MBSE model, like in the diagram here, that might be mastered in multiple solutions and provide some traceability between them. And so in this case, we have Enterprise Architect. You might be designing the model in IBM Rational for requirements, Integrity, which is now called just Windchill, and Teamcenter for the parametric design and bill of materials. And providing that you have all these different domains that have different repositories, provide traceability between them. And traceability, right, if you have this just the model and you're trying to investigate in order to come up with what that used to be in the past, is very hard to do, right? It's a huge time crunch, and sometimes could result in errors that are fairly critical. So if you create these relationships within the model itself, and also between these different systems, then you'll be able to refer back to that as your digital thread, as the traceability that you need, and really have like a complete and comprehensive solution, that shows all the information in one place. So we're finding that there's more needs for the digital thread, also just because of general complexity. So there's a longer time to market and larger developments. More suppliers are being brought in order to lower costs overall. There's different integrations. There's more siloed components. There's maybe an overall volume of components increase and complexity of each individual components, as well as software and other disciplines that are merged together. And really, this kind of drives a whole cumulative risk that you're trying to manage. So really bringing together that information and have it visible and have it allow to validate early on within that type of system model can really bring that visibility to everyone and bring those changes that are required up front, right? And we all know that changing is costly, the most often in the field, right? So if you have to, in operation, change things, that's going to be a big issue, but that cost goes up over time. And if you can expose through that validation of this integrated data model those changes early on, you're going to see a lower cost and a quicker to market and a more viable solution. And then you also get the benefit for the sustainability and the long-term operation of having that knowledge retained within your digital thread, that really then you can focus on and utilize in the long run for that type of sustainability. So moving on, we're going to talk about integration solutions and strategies that we can take in order to overcome these challenges. So we find that there's a number of use cases in building your digital thread. And I'm going to demonstrate a couple of the common ones to provide traceability and automation and synchronization between systems. So in this diagram at the bottom, we've got a number of different clients for mechanical or electrical CAD analysis, software development, requirements management, manufacturing, and others. And then in the middle, we have a layer of repositories. And these are systems that are going to permanently manage that data and allow for users to have a record of that data that they can refer to. And this is important because traceability is going to require that kind of record. So one of the first use cases that we see is a PLM to ERP or MRP or MES integration. And this is the most common use case, right? Moving from an engineering release to manufacturing or procurement or something of that nature. And that replicates the EBOM. Sometimes replicates an MBOM, and normally triggered on some type of release in order to process the data, and normally needs to copy it. So this isn't traceability. This is going to actually have a copy of the data so they could use it in the other system, not something like a link. Another use case, a little less common, but growing use case is replication of CAD between your PLM to your SDM or SPLM system that's used as a repository for analysis data. So you need the actual CAD data in full format, and we advise you use the native CAD, even if you might use a derived output like STEP or JT. But if you have the native CAD, you can then leverage that in any means you need in order to process that data. And then on the return trip, once you're done with that type of workflow to process the data, you'll have a report or some results, and you can feed those back to PLM to kind of provide the full circle and incorporate any changes that are recommended. We also have traceability and dependency between PLM and ALM data, and that could be for changes, but also for ECAD and software development. We've got systems engineering linking, and one of the strategies that we employ with this is to be able to use a linked data concept, so not replicating data to the systems engineering repository or systems engineering client, but be able to provide traceability and exposure into these systems so that you can reference the right data to provide a real overall structure. There's other use cases like further down the line in manufacturing for forecasting, scheduling, and other types of orders. And then at the cloud edge and also in manufacturing, providing usage reports and real-time data from manufacturing so you can adjust that, or products out in the world, providing feedback and maybe pushing change requests through ALM, or issues, or just general usage so that you can change your design or see where you can make improvements. Finally, I'd like to discuss ProStep's API for the digital thread. And these are practices and commercial solutions that you can use within your enterprise in order to solve some of these challenges. So ProStep has developed over the years a comprehensive set of packages to perform these types of integration solutions that we're calling the ProStep API for the digital thread. And at the core of that includes 4 use cases. First, replication. And that's when binary data is needed between systems to be copied so that you can use it. So taking data out of one system, mapping it to that other system's data model and putting it in there so that you can consume it and use it in that other system. And that's needed, right? So in the case that you are doing analysis in your simulation data management system, then you might need the 3D data to perform that. The second is federation, and that's not actually copying the data, but just making a reference of it. So in this cross-domain configuration management that we were discussing, creating those references allows you to pull that data and consume it when you need it, but not have the burdensome activity of generating a lot of copied data within that system, which very much simplifies the types of integration. And gives you a little bit more of freedom to create data just by reference. The third, collaboration, and that's the ability in order to pull out data and be able to format it in a way that you're able to share it with your customers and suppliers. So maybe that includes step transformation and then also secure data exchange and encryption, digital rights management, and others. And then finally, communication, and this is generating, we're calling technical data packages, but that could include not just a manufacturing deliverable, that it could be maintenance manuals, it could be SysML documents, it could be all sorts of different things in order to effectively use derived output from one system to copy to another. So that those users within that system don't need to go to another system in order to use that data. So make it available where the users are by creating some intelligent documents that can be shared across them. And then, we connect all these systems together with our ProStep connectors, and then make all this data available either through this background processes, different interfaces like SOAP, REST, and standards like OSLC for linked data, and secure data exchange, as well as 3D PDFs and step conversion. So really a big, comprehensive overall toolkit in order to provide the integration that you need. So ProStep has 3 main products that they use with the API for the digital thread. The first is on the upper left, the OpenDXM Global X product. That's a secure data exchange tool that allows for deep integration into Teamcenter, as well as automated workflows for transforming and translating data that you need to send to your OEMs, and also doing quality checks and translations and importing data to Teamcenter that you might have from your suppliers to really have a quality gateway. So automating a lot of that work that you might need in order to support the delivery or receiving information, and doing it very securely with nice audit trails in order to ensure that that data doesn't get into the wrong place. The second is our PDF Generator 3D product that allows you to generate either 3D PDFs for technical data packages or HTML5 and other types of output. And this is really to take CAD data or other data, combine it from different domains, and then make it accessible to the wider audience who does not have a CAD seat. So that could be with suppliers or sales or marketing or service or other types of domains that don't want to have a heavy CAD or even a lightweight type integration. And then the third being OpenPDM. And OpenPDM is our flagship integration hub that allows you to do this cross-domain with the connectors that it has. And got a lot of different connectors for a lot of different systems. There's just a sample of them on here. But each of these connectors allows for export and import of data through the systems, and then also federation and providing links to these systems, and a neutralization of all this data in the middle of the OpenPDM in order to do things like create step data, to pull CAD out, and provide different automated scripts in the middle in order to accomplish what your goals are. So using our OpenPDM platform, you can really enable this type of data to go in and out of the Siemens Teamcenter and get that integration you need for the digital thread. So that might include data through CAD controllers that we have. So we have specific controllers that can use the interfaces for the CAD systems the way they're intended to use with UG-clone and IPEM batch control or SWIM batch control or TCIC batch control. And then also a connector, our Teamcenter connector, that uses the Teamcenter SOA interface in order to operate kind of like a client would with Teamcenter and go through the normal APIs and that respect access controls and really work like a person would within Teamcenter. Secure collaboration using our OpenDXM Global X product also provides those automated tools and deeply integrated into Teamcenter in order to package data and take it from your domain to another, like a customer or a supplier. And this is in combination with some of our connectors that we use from OpenPDM, and then also with our PDF generator in cases in order to get the purpose-driven and role-based formats that you need. It also comes with a wide variety of tools to make it as easy to use as possible. So that means Outlook integration, Dropbox-like functionality for Explorer integration, and other types of tools and integrations with common systems. Finally, using our PDF Generator 3D, we can generate both 3D PDFs and HTML5 data, with good fidelity, including product manufacturing information, possibility for exporting other types of data like STEP, and utilizing the same OpenPDM connectors in order to have that nice deep integration to Teamcenter, and being able to grab that CAD data and utilize it within these 3D PDFs. But then also supporting, maybe other use cases, such as getting data and using a very strong digital rights management to harness that in order to send the data out, but be able to revoke the privileges out in the wild. Different supplier and quote packages that can be created for ERP and purchasing, using a combination of data formats like STEP 242 and PRC within 3D PDF to create good long-term archiving documents, capturing different types of data like simulation data analysis, or providing work instructions and maintenance manuals for MES and ERP. So a wide variety of different use cases you can use with this. And finally, I'd like to thank you for attending. I hope you found this informative. And if you have any questions, feel free to reach out to us. We're on the web, or you can email me at brian.scouten@prostep.com. I appreciate your time and attendance.